Day 15, Grounding, Multi-Query, Answer Validation. This is one of the quietest, most dangerous days on the exam, not because it's complicated, but because AWS hides these questions inside polite wording. This day tests whether you trust answers blindly or whether you build systems that deserve trust. Imagine this. A space agency uses an AI assistant to analyze satellite incident reports. Engineers ask questions like, what caused the power failure last time? Has this fault happened before? Which subsystem usually fails first? Each satellite costs hundreds of millions. If the AI guesses, overgeneralizes, or merges unrelated incidents, a satellite is lost. So this system must do three things perfectly. It must stay grounded, it must search from multiple angles, and it must verify its own answers. That is day 15. Let's start with the foundation. Grounding. Grounding means forcing the model to answer only from retrieved evidence. No guessing, no general knowledge, no creativity. If the evidence is missing, the correct response is, I don't know. That is not a failure, that is correctness. Grounding is not about lowering temperature. It's not about choosing a smarter model. It's not fine-tuning. It's not polite prompting. Grounding is a hard constraint. The model may only speak using what it was shown. Here's the difference. An ungrounded answer says, power failures usually happen because batteries degrade over time. That sounds reasonable, and it's wrong. A grounded answer says, according to Incident Report 2019 A17, the power failure was caused by a voltage regulator fault in the EPS subsystem. Only one of these is acceptable in production. On the exam, grounding is the answer whenever you see phrases like answer only from documents, prevent guessing, no external knowledge, cite sources, fact-based responses. That's grounding. Now let's talk about why grounding alone is not enough, because users ask terrible questions. An engineer asks, why did the satellite fail last time? That question is vague, ambiguous, open to interpretation. A single embedding search might retrieve one report, one angle, one partial explanation. That's how systems miss critical context. This is why single query RAG fails. So we introduce the next layer, multi-query retrieval. Multi-query means you don't trust a single search. You ask the same question multiple different ways. Here's how it works. The user asks a question. Before searching, the system rewrites it into multiple focused queries. Each rewritten query is embedded separately. Each one searches the vector store independently. The results are merged and deduplicated. Only then do you move forward. Back to the satellite. The original question is, why did the satellite fail last time? The system rewrites it as, what was the root cause of the previous satellite power failure? Which subsystem caused the last satellite outage? Incident report describing previous satellite failure cause. Each query retrieves different evidence. Together they build a complete picture. That's how recall improves without guessing. On the exam, multi-query is the correct answer when you see vague user queries, missing context, incomplete retrieval, improve recall, multiple perspectives. That's multi-query retrieval. Now comes the final safety net, answer validation. Because even with perfect retrieval, models can still missummarize, overclaim, or connect dots that don't exist. Answer validation exists to stop that. Answer validation means checking the model's answer against the retrieved evidence before returning it. In other words, show me where you got that from. Here's how validation works in practice. The model generates an answer. Then a validation step asks, is every claim supported by the retrieved text? If not, the answer is revised or rejected. Back to the satellite. The model answers, the failure was caused by a solar flare. Validation checks the retrieved reports. No document mentions a solar flare, so the answer is rejected. The system responds instead, the available incident reports do not identify a confirmed cause. That's not weak, that's safe. Answer validation may include consistency checks, self-review prompts, citation requirements, or fallback responses when evidence is missing. The exam does not care which method you choose. It cares that you validate before trusting. Now lock in how all three layers work together. Multi-query improves what the system can see. Grounding limits what the model is allowed to say. Validation checks what the model actually said. Together, they create production-grade RAG. This layered defense is exactly how AWS thinks. In AWS terms, an exam-friendly stack looks like this. Tighten embeddings v2 for embeddings. OpenSearch serverless for vector or hybrid search, Claude Sonnet for query rewriting and answer generation, prompt rules for grounding, a validation step to verify claims. Now avoid the traps. Lowering temperature does not guarantee correctness. Using a bigger model does not fix hallucinations. Fine-tuning does not make answers factual. When answers are wrong after RAG, the fix is retrieval quality and validation, not model choice. Here's the one sentence that solves day 15. Grounding limits what the model may say. Multi-query improves what it can see. Validation checks what it actually said. Say that once before the exam. Final self-test. A RAG system retrieves correct documents, but answers sometimes include unsupported claims. What should you add? Answer validation. That's day 15 mastered.